I'm going to get descriptives and collinearity diagnostics. And I might even do case-wise diagnostics and identify outliers that are 3 standard deviations from the mean. You can also do like 2 standard deviations from the mean. Just depends on how sensitive you want to detect for outliers. All right. So click continue. Under plots, this is where you look for homogeneity of variance or homoscedasticity. You do z predicted on the x-axis and z residual on the y-axis. That's going to give you a residual plot so that you look for homoscedasticity. Right? And you can also get a histogram of the residuals, which will tell you whether or not they're normally distributed. You can also get a normal probability plot, so that's like a PP plot of the residuals to see if the residuals are normally distributed. Continue. Under options, no, that's good. Under save, no, we don't want to save anything. Oh, notice that you could save some Mahalanobis distances, Cook's distances, or leverage values. We'll deal with those on Monday. Tuesday. We will talk about outliers and how that influences regression analysis, and so that will be on the test. Yeah. All right. I just want to kind of point that out for you. All right. Click OK. Here we go. Here's our collinearity diagnostics and our VIF statistics. Right? That's right there. So it's close to 1, not much of a problem here. Right? We have case-wise diagnostics that tell us about outliers.
Question on the VIF. Is that pretty rare to get them to be the same for each?
Oh, because there were only 2 predictors.
So that's how it's pretty much what it's going to be.
Right, because remember the VIF is determined by all predictors predicting the one predictor, or all other predictors predicting the other predictor. And so since there's only one other one, that's basically the correlation coefficient. Based on this, the correlation coefficient is 0.85 minus 1 minus 0.85 equals the R squared of the relationship between these 2 variables.
So they'll always be the same, it's just
Yeah, because it's this one predicting that one, and the other one is that one predicting that one. It's going to be the same. Yeah, so take the square root of that, and that'll give you and take the square root of 15%, and you will get, where is it? 0.387.
what did we take the square root of? Just
15%. The 1 minus the tolerance. Right, but that's only the case when there are only 2 predictors, right? When there are 3 predictors, it will be 2 predictors predicting the 1 for each one. Make sense?
So what the square root of the tolerance did you just say? Is the Pearson correlation?
When there are 2 predictors, because it's the standardized, it's the R square, right? Which is also the same as.
Oh yeah, okay, never mind.
Right. Good. All right. This histogram tells us whether or not our residuals, our E sub i's, are normally distributed. Remember, it's IID normal. This tells us if it's normal. Right? The VIF tells us if they're independently distributed. A high VIF means they're not independently distributed. Right? And then the residual plot, so this is the PP plot of the residuals. It's the same thing as the histogram telling you is it normally distributed. Right? Here is the residual plot. Right? And what are you looking for? A hot dog. Do you have something that looks sort of like a hot dog? Let me position 0. So the question is, as you go across this line, do you have equal spread of scores as you go along that line? Right? Oh. Yeah, it's not horrible, right? We don't have a distinct fan shape, although it'll, because you don't have very many scores down here, it's hard to tell, right? But as you get more and more scores, you see that they kind of go above and below the line, right? You don't have many scores down here. So what you could do is you could redo this regression analysis, selecting out the extreme scores and see if you get the same relationship. It's going to take out the outliers, right? Where you would have homogeneity, you have stronger homoscedasticity, right? And you have to make better predictions, more confidence in your predictions.
When you take out the outliers, you just eliminate it from the row of the original data?
You do select cases. You select cases if, above a certain level.
Would you do that after transforming it?
You could transform the scores. You'd want to transform the scores if you have clear, non-normal data. Yeah. And so that was the two things that we've missed. One is that the independent and dependent variables are normally distributed, and that there's a linear relationship between the independent variable and the dependent variable. So how do we determine those? Scatter plot, right? So graphs, scatter, and let's do a scatter plot matrix with quality, publications for faculty, and students for faculty. So, does it look normal? Does it look like a linear relationship, or does it look like curvilinear, or does it look weird?
Yeah, two of them look pretty linear.
We're looking at the dependent variable and the predictor variables. So this row.
Which row?
This row. The dependent variable and the independent variables.
The first one looks linear. The second one looks like a show.
There's basically some
Yeah.
outliers
So there's something going on, and especially something going on with high levels of student per faculty. Right? So this one we might consider selecting out these cases and just looking at this little tube right here. Right? Make sense? So this is where the outliers question comes in, and we'll talk about that.
So what do we need to know for chapter 6 and 7?
All right.
We should just make this chapter 6 later.
Yeah, the tendency will be to focus on these regression questions and forget that we actually had other